Hello everyone, welcome to the introduction video of SHAARP. In this video, I'll walk you through some basic features of SHAARP and what you can obtain from the software. The current GUI you're looking at is the SHAARP interface. It contains 5 basic components. The green bar shown at the top is a progress bar. It tells you the progress of the current evaluation. The gray region is the main panel. It covers some basic information about the SHAARP. The green button shown at the top right is the update button. By clicking it, the program will know you have finished all your input and will execute the calculation. The panel to the left is the input panel. You'll input all the settings and SHAARP will run the calculation based on the input you have provided. Finally, the panel to the right is the output panel, which will display all the results generated by SHAARP. The functionality tab in the input panel provides key capabilities of numerical simulation and analytical derivation. The default output is the user guide, which is you're looking at. Here, you will find useful information about SHAARP, including try-preset demo to obtain your first evaluation. And also, we have provided more resources, such as GitHub page, documentation page, as well as frequently asked questions. In this demo, I'll use Liefeld as an example to go through the input setting and output result. First, I will go to the functionality, click SAG simulation, and then scroll down to the case study and click Liefeld, and then click update. The output contains 3 rows, and they reflect the settings you have provided in the input panel. The first row contains the probing geometry and the polarization relations. By putting cursors on the plot, detailed descriptions of each plot will appear. The second row contains SAG polar plots as a function of phi and psi. Those 2 angles are displayed in polarization relations, as you can see from here. The third row contains Snell's law of ordinary and extraordinary wave, and the ellipticity for the instant wave. Now we can modify the input section and see how the result will vary. In the polarimetry setting, you will provide the instant angle, ellipticity of instant light, polarizer in analyzer settings, and 2D or 3D schematic. The default instant angle is 45 degrees. You can change it to 30 degrees, for example. The current setting for both polarization angle phi and SAG polarization psi are rotating together. We can keep the polarizer rotating and fix the analyzer psi. We can also choose the 3D schematic and then click update to update the results. Now, as you can see, the plots for the probing geometry and polarization relations are in 3D. And the instant angles are changed based on the input you have provided, and you can interact with the probing geometry. Notably, the psi in the polarization relations disappear, and that indicates a fixed angle. Next, we'll modify the crystal orientation section. In this section, 2 pieces of information will be asked. One is HKL crystal plane, and the other is the direction perpendicular to the plane instance. Suppose we want to change to the z Liefeld, we simply need to put 001 in the first row and 100 in the second row. Click update, and you can see plots are changed. The orientation change will also be displayed in the probing geometry. If you look at the relation between L1, L2, and L3, as compared to the Z1, Z2, Z3. The next 2 sections are linear optical tensors for both fundamental and SAG frequencies and SAG susceptibility. Depending on the materials, you can modify those 2 contents here. Note that all the tensors are provided in the crystal physics coordinate. The case study section contains a few examples with default properties. You're welcome to explore the rest of the examples. Next, I'll show you how to obtain analytical solutions. Analytical solutions are critical, especially connecting experiments to the fundamental properties. In the functionality section, you can choose either partial analytical solution or full analytical solution. Partial analytical expressions give you the analytical results with only SEG susceptibility as unknown parameters. On the other hand, the full analytical result provides comprehensive symbolic results without numerical input. To obtain the partial analytical expression, you can simply click Partial Analytical Expression and click Update. This will generate SAG expressions as a function of phi and psi with unknown SAG coefficient. The expression shown in the middle are the targeting expressions. This expression is not related to the SAG tensor values provided in the input panel, but we do provide expressions with assigned SAG tensor values in the bottom two expressions. We also provide copy capability to copy expressions directly from SHAARP, and you can paste the expressions into other Mathematica notebooks or Microsoft Office software. Finally, to access full analytical expression, you can click Full Analytical Expression and click Update. This calculation will take about 10 seconds to a few minutes, depending on the devices, and you can refer to the progress bar for the evaluation progress. Once the calculation is done, it will provide a complete set of expressions ranging from linear optical response to nonlinear optical response. A summary of symbol can be found in the documentation page, which can be accessed directly here. It also provides copy capability so that you don't have to copy manually. It's worth noting that we only display expressions of reflected electric field at a 2 MHz frequency. The rest of expressions, if you scroll all the way down, those expressions are hidden, but you can still access using the copy button. To view the entire expressions, SHAARP will generate a separate notebook called Full Analytical Expressions, and you can find it in the same directory as the SHAARP notebook. If you open the folder, you will see another notebook is created. So let's go back to the user guide. So here is a quick look at how to use and interact with SHAARP. Thank you for watching this video, and I hope you find this demo video useful, and I hope you enjoy using SHAARP. Thank you very much.